And I'm assuming you can change that to like stdl to be something else.
Yeah, we'll play around with that presently. So questions up to here.
So we're making a string, right?
Okay.
I don't know if you know this already. Like I'm working on the print line for the fraction function. I want it to return the number, fraction symbol number. Do I have to say new string, or do I just put it in?
You can get away with a lot of string construction just using double quotes. So you can say like string s equals numerator plus slash plus etc.
Okay.
And it will automatically create a new string called s, and it will initialize it to this value.
I got it to work just by returning the right.
Or you can just return that.
So I can, okay.
Right. Or you could say string s equals new string parentheses quote all of this stuff.
Yeah.
Or use any of the various string methods to assign this value to it. But strings are another one of these things that let you get away with some shortcuts because they're so popular. Right? We don't want to have to say new string every time we create a new string.
I found though that if you only return a numerator because you have like numerator divided by 1, it actually wants you to convert it to a string before you.
Yes. So if you say something like string s equals I, where I is an integer, that will complain.
Yeah.
Because you've got an integer on one side of an assignment and a string on the other. So you could do I plus nothing. That's the cheapest way to do it.
There would be a two-string function there.
Yeah.
I got two strings.
Yeah. Well, it's not up.
Say what? I is not an object though, it's a primitive.
Yeah, you have to put like
Oh,
actual
you have to.
integer.
So you could cast it and then call it toString method, but concatenating nothing to it is a easy way to force it to be a string.
I cast it as an integer object and then use two strings.
Uh-huh.
What's up with that A? Was that just a mistake, or are you saying I?
That's a scribble.
Okay.
That's two scribbles.
I'm guessing the compiler will complain, like, so in the toString method, if every class has a toString method in it, right? So if it is trying to be put in as a string, it'll just automatically be converted into a toString, right? Or to whatever is in its toString.
Well, two string is relative to whatever class you're working with.
Yeah, so like if you were to,
Oh, so you're saying.
I'm trying to, I had a thought, like if you somehow, that's why I said the compiler would complain, because you could get into an infinite loop if it automatically just converted itself into a string if you just returned it in a toString, but I don't think it would work because you're returning a class, not a string.
If you returned an object inside toString,
Yeah, that would complain.
and it tried to convert it.
Because then it would.
I don't know if you can actually force it to try to do that though, right? So let's see, so if you had a class blah, and inside here you have an integer x, and you have a toString, and let's say you have a blah b, and maybe inside your toString try to return b.
Yeah, that's kind of what I mean.
Right, so what you're really trying to do is return b.toString, and that looks like it would be recursive.
And that's kind of what I was getting at there, is if that just keeps going.
Yeah, I think the compiler will probably let it slide.
Really?
Wait, wouldn't that complain because you have to specify what two strings returning?
Yeah, so it's got to be a string.
Yeah.
Right?
But then when it has b in there, wouldn't it try to convert that?
I think it'll try to convert that by calling the toString method of blah.
Which is that. And then,
Right.
But that has its own b.
Right.
So.
I don't know, give it a try. If we see smoke coming out from the side of the room, we'll know what happened.
All of them are simple to know, so.
Yeah, that would be fun to try, but I won't try it right now. I'll try it in between classes. All right, so other questions, comments? PA1 questions? You should be, at this point, pretty close to finished with PA1, I would hope.
Yeah.
Dotting the i's and crossing the t's, right? Hopefully you've got constructors and some form of a two-string, and are having some success with creating return values that are also fractions. If you're not at that point, right, we need to talk like really soon, like today if possible. Because you don't want to try to do this all at the last day, right? Conceptually, there's a lot of things that need time to percolate to really kind of like be workable with. So come see me today if you're feeling behind. All right, how much have we talked about arrays yet? I know we looked at the string argument, the string array, that's your arguments, but have we looked at arrays beyond that?
We had a
I don't-
length component.
We had a what?
There was the length component, but.
Right, okay. So let me just mention a few things about arrays. And your next ODP, which I'll post tomorrow, will be dealing with arrays. So we can declare data to be an array of integers by something like this: integer bracket bracket data, semicolon. That's a declaration of data. It's not an initialization. Okay, so this is in C, like saying integer star data. We're declaring what type of variable data is, but we're not giving it a value yet. We're not initializing it. So at this point, if I try to say data bracket 2, right, I'm going to get an error because data hasn't been initialized yet. Just like over here, if I say data bracket 2, right, I'll get a seg fault. So before we can do this, we need to make data actually point to a chunk of memory that can hold integers. And so we use the new statement. And we might say something like this: data equals new integer bracket 10. Okay, that's what we used to use malloc for. And once we do this, now we can say data 2 equals, some value, and that's fine. So arrays of integers, characters, doubles, pretty straightforward analog to C, right? Make your declaration, and you can say equals new integer right there, or you can set it up later on, just like with integer star data and malloc. It gets a little different with arrays of objects, though. So, so here's an array of rectangles called data. Here we've actually caused data to point to 10 rectangles. Okay, so now data bracket 2, that's been set up to be a rectangle. Okay, it's been declared to be a rectangle. But that specific object has not been constructed yet, right? I mean, I could ask you, well, what's the height and width of this rectangle? Data bracket 2, and the answer is it doesn't have a height and a width because you haven't made this rectangle yet. Okay, all we've done is declare that this is a rectangle, but we still have to construct it. So we can do something like this. And now element 2 of this data array is a 12 by 5 rectangle. But if we don't do this, and we try to pull out data 2's height, right, we're going to get an error because data 2 hasn't been constructed yet. So we kind of have this two-part process we have to do when we're dealing with arrays of objects in general. One is declaring this thing to be an array, right? And using the new keyword to actually make space for those objects. But we also have to give these things values, either by constructing them or setting them equal to something else, right? But somehow we've got to give them a value, and that's a pretty common error when you have these arrays of objects. You'll keep getting null exceptions because you forgot to actually give this thing a value. So keep that in mind, and when it comes up, we'll talk more about it. All right. So we've been dancing around a bit of an issue here. There's things like int, float, double, char, and then there's things like rectangle and string. Yeah, so these things, these are primitive data types. These are bona fide objects, actually classes. But when we have a rectangle R is actually an object, right? It's an instance of this rectangle class. When we say integer x is not really an object in the same sense that a rectangle R is an object. These are primitives. They're built into Java, and it saves you from having to do the following. Integer x equals new integer 10. Now that constructs an object named x of type integer, and we pass a 10 to the constructor, which says give x the value of 10. Okay? By having a primitive type called int, we can instead say int x equals 10, which is kind of what we're used to doing. So we can use several different types of primitives, but understand that they're a little bit different from the actual class called integer or float or double or char, character. So we can look at these actual classes. So here's the integer class, and we can construct it by passing it an int, or by passing it a string that we want to use to represent the value. But it comes with all these other methods, right? We can count how many ones there are in the binary representation of integer by calling the bit count method. We can compare two integers numerically by calling the compare method and passing it two ints, and that really just subtracts them. Gives you back something positive, negative, or 0. We can convert an integer to a float by saying float value. We can also cast by saying float in parentheses, right? We can convert to different types. We can reverse the bits in a number. That's kind of a weird thing to do, but if we want to do it, there's a method for doing it. And we can do conversions to different formats, binary, hex, octal, or to an arbitrary radix. So if we want to write our number base 7, we can call toString number comma 7. There's all these different methods that we have available. And there's also some fields defined for us. There's a field called max value, that's the largest integer that we can represent. And there's a min value, that's the smallest, the most negative number. This is the number of bits used to represent an integer, and so on. But in general, when we work with integers, we're just going to say something like int x. Make it an integer. Yeah?
So if you make an array of integers, and then you say, make a variable int x, and you set it to one of the values from that array, if you modify that variable, will it modify the value?
No, so that's going to copy the value.
Okay.
But this is a really interesting question. So integer x equals data 2. Okay, that's going to read this. It's 17, set x equal to 17. They're totally separate from each other. But when we do this with objects, right, we sometimes get a different situation. So if I have a rectangle array, well, more even nothing to do with it, arrays. right? When I say R2 equals R1, those are the same rectangle. Okay, if I print them with a default two-string method, I should see the same internal representation of them. So if I change R2's height, R1's height should change. Okay, that's a good thing or a bad thing depending on the time of day. But this will eventually get us into something called deep copy versus shallow copy. Because if this object R1 has other structures inside it, and those structures have other structures, and we say R2 equals R1, the question is, does it copy everything from R1 into R2, or does it just copy sort of the top level with pointers to these other things? And that can get us into some issues later.
So right before you say R2 equals R1, if you say R2 equals new rectangle or whatever, what would that do?
So if in here we say R2 equals new rectangle, and then we say R2 equals R1, this rectangle basically gets abandoned, right? It's essentially lost memory. Just like if we say node equals malloc, and then we say node equals root arrow left. The thing that we malloc, there's nothing referring to it anymore, it's basically lost memory. The difference in Java is there's something called a garbage collector, and it runs in the background of the JVM, and it looks for memory that's not being referred to anywhere, and when it finds something like that, it'll reclaim the memory. So we don't have permanent memory losses, theoretically, in Java. So yeah, don't do that. All right, so another primitive type is Boolean.
Oh, finally.
And Boolean is a genuine type in Java. Okay, it's a type of variable, and it can take on two values, true or false. And it's not the same as, say, 0 or 1 like in C or some other languages. Okay, it's just true, TRUE, lowercase, or false, FALSE, lowercase.
Fine.
Yeah.
I've been missing this one.
And so we can do things like Boolean flag, and now flag can be either true or false. And we could say flag equals true. We could also say flag equals x equals y. And now if x equals y, flag will be true, otherwise it'll be false, and so on. Anything over here that has a logical truth value, we can assign to flag. But we cannot say something like flag equals 1. The compiler will complain about that. We can say if flag, but we cannot say if 1, right? Because in an if statement, it expects something with a logical value. So the tricks that we use in C sometimes, where we have a variable, and if it's 0, we want to do something, and we just say if not x, right? That doesn't work in Java. So you lose that, but you gain a genuine Boolean data type. So car is a primitive type. It's a single character, but it's the primitive version of a class called character. And character has lots of stuff to it. So let's just look at some of the methods. So character, we can do things like where the is like is digit, right, to see if a character is a digit or not, or is letter to see if it's a letter, or is letter or digit, is lowercase, and so on and so forth. So all these things that we used to pull out of ctype.h for no apparent reason, right, they're all part of the character class, which is where they belong, because these are things that you use with characters, right? So there are methods available in the character class. All right, so let's talk about I/O. So you'll hear me say this a lot. I said this a lot in the past courses too. On the subject of I/O in Java, right? There is 10 trillion ways to do input and output in a Java program. There's tons of different classes, and they're all subclasses of other classes, or they're superclasses of other classes, and they all have lots of different methods inside and ways to construct them. And there's all this stuff you can do for I/O on Java. Okay, and we don't have time to go through most of that. And for this course, we don't need to go through most of that. What we really want is a way to do input and output, okay? From standard in to standard out, or from files, or eventually from sockets for doing networking and things like that. But we really need a tiny little subset of all the functional behavior that's available to us in Java. So I'm going to talk about a very narrow path through all of this complexity, okay? And you're responsible for knowing how to do the things that we're talking about in class. So we're going to talk about using the scanner class to do input. And we're going to talk about using the file class to do input and output with files. And I want you to know how to use those, okay? And those are fair game for testing. If you want to work with other things, if you want to get into buffered writers for PA2 or whatever, right, you can do that, but you still need to understand the things that we're going through in class. But you also want to avoid, right, I can't get scanner to work, so I looked online and I found out how to use a such and such, and I started doing that. And now the night before my assignment's due, nothing's working because I don't really understand such and such, and I have no notes on it because we never talked about it in class. Okay, it's more useful probably at this stage to learn the stuff that we're talking about, because the things we say in class will make more sense, they'll be more relevant to what you're doing in your code and so on. So if we talk about scanners for doing input and it's not working for you, don't just immediately go to Google and find a different way to do input. Okay, ask questions about it, post something on discussion, send me an email, come to class, whatever. Does that make sense? All right, so that's just my standard disclaimer. So scanner class is kind of like Java's version of scanf, but a whole lot nicer.
Oh, so these are
Say what?
these are in the documentation.
Yeah, you can get, this is the documentation page basically, but usually I just go to Google and I Google Java space and the name of the class, and maybe I'll put the word class after if it's something not too distinct like math, but that'll usually bring you up to a page from docs.oracle.com.
Well, I'm always looking at this documentation, so it's nice.
Yeah, yeah. So lots of words in the front that we can skip over. But the constructor for a scanner can be constructed by naming an input stream. Okay, and that basically says where we want to read these input values from. And we already know about one input stream, and that's system.in. It's the counterpart to system.out that we use for print line. Bless you. So if we construct a scanner using system.in as an argument, that will give us this scanner object that can be used to read from system.in, which is really just standard in. So it's normally the stuff we're typing on the keyboard, but if we redirect input or we pipe from a command into our Java program, it's whatever we're using to feed standard in. So we construct, and then we have a variety of methods available, and most of these come in pairs. It's has next something and next something. For example, if we want to input doubles, we can say next double, and that will give us the next double that it finds in the input stream. Okay, so it's kind of like an scanf with a %G. And to know whether or not there's a double sitting in our input stream, we can call the function hasNextDouble. Right, it's a method of the scanner, and it'll return true or false, telling us whether or not there's a double sitting at the input ready for us to read. So usually we call has next double, and if it returns true, then we can say next double, and that'll return the actual double value. So I want to start with just one particular pair. So has next line tells us whether or not there's another line of input available. And if it returns true, then we can call next line, and that'll actually give us a string, which is the next line of input. So when you put this together, it's pretty joyous to work with. Alright, so I'm making S my scanner object, and I'm going to construct by saying S equals new scanner, and I'm just passing it system.in. Once I do that, S is basically something I can use to read from standard in. Alright, so minimal program here, right? We're just going to call next line, take the return value from that, store that in buffer, which is a string, and then we'll print out buffer. So it's telling me it cannot find the symbol scanner, right? And gives you a little caret showing you where the problem is. And scanner is not part of the Java language. Okay, like C, the Java language itself is very, very simple. Scanner is the name of a class, but it's not built into Java. So we've got to tell it where to find this class. Something like an include statement. So when you have the documentation for a class, if you go up to the very beginning, you'll see Java Utilities Scanner. That's the package where scanner is located. And so we need to specify this, and we do this with an import statement. So in the very beginning, we want to do the following. Right, import java.utilities.scanner. And you can wildcard this. We could import java.util.star, and everything in java.util would be available to us. But usually you want to be more nuanced. So this should tell it where to find scanner. And now if we compile, that compiles fine. So let's go ahead and run this. And we'll type a line of input, and it tells us that's the buffer that I got back from scanner.next line. All right, so let's put this in a loop.
You could do something like round buffer equal s dot next line, and like do something like dot is empty, maybe.
We could do something like that, except that when we hit the end of the input, it doesn't give us an empty buffer. In fact, if we run this with an empty input, and I'm just going to use Control-D to say that's the end of the input, I get an exception. Okay, saying I tried to read the next line, but there was no next line.
So you need to check and see if there isn't.
So you have to check and see if there's a new line before you try to read it. And that's what this has next line method will do for us. So has next line returns true if there's another line of input. And it tells us the method may block while waiting for input. So what does blocking on input mean? It means that when I call has next line, it's going to sit inside that method until input is available. Or it detects the end of the file, meaning that it can return false from this. All right, so let's make a loop. I put a J.
X in the next line.
It has net line, good. All right, so while this has next line, we'll go ahead and read that next line, we'll print it out, and we'll just keep looping. Okay, so it's reading one line at a time, and I can hit a Control D to signal end of file, and then has next line returned false, kicked us out of the while loop, and the program exited. So I can say who, and I can pipe that into Java main, and now standard in is coming from the output. Well, let's just do this. Let's have some fun instead. Oh.
Oh my goodness.
No, fail.
Apparently this environment is not worth its salt. If anything that you said in 224 is easy to go by.
Yeah, I'm gonna have to go back and delete this from the video. Can't let people see this. I'm shocked. I blame upgrades. Something must have upgraded. All right. So we can take that and we can pipe it into Java main, and it reads from the output of that command instead of from our usual keyboard. So yeah, we got a disassembled cow there. And we can also redirect input with a less than sign, and now it's reading its own source code file and printing that out. So pretty easy to do input from standard in, right? Has next line and next line will do it. Another option, and this will be helpful in PA2, is has next and next. So has next without any modification says return true if the next, if the scanner has another token in its input.
Yeah, sure. That's anything.
And next line, or just plain next, finds and returns the next complete token. Okay, complete token is preceded and followed by input that matches the delimiter pattern, and the delimiter pattern by default is just a bunch of spaces. So this will basically break your input into things separated by spaces and return those one at a time. Okay, something that's sometimes useful to do. There's a delimiter method if you want to change what the delimiter is. If you want to read things separated by periods, right, you can change the delimiter accordingly. So we can compile this up, and then if we run this on its source code, each time that next returns, it gives us another piece of our file where the pieces are separated by spaces. And that'll play into PA2 nicely.
That's like how some compilers work.
Yeah, I mean, if you were trying to compile or interpret Java, you would probably do something similar to this.
That's much easier for people to understand.
Yeah, because anything that ignores white space, right, that's probably a good way to tokenize on the first pass. Now this will also take things that are inside quotes, and it will split those up if there's spaces in the quotes, because it's really not paying attention to quoted strings. So you'd start to worry about that a little bit. Yeah.
So can you have multiple delimiters? Like,
That's a good question.
Yeah, like if you want a space and a period or something like that.
the patterns, maybe there's like a, we do
So there's a pattern function.
Yeah. So
Yeah.
what's the pattern class?
Well, so we can go into a whole regular expression thing, right? So there's a regex class, and you basically write a pattern, you compile it, and then you can feed that to regex, and you can match things from that. But I'm curious about the delimiter by itself.
The delimiter function.
Yeah.
Yeah, I wonder if there's a set, because that returns.
Oh, okay.
So use delimiter. So we can feed it a pattern, so we can go crazy with that.
Oh, there you go. Or you can also send it a string.
You can send it a string, or we can send it a pattern, and a pattern can be can compile a regular expression. So yeah, we can get really sophisticated with this. Another good reason to know regex.
Is Latin in Greek?
Yeah, right.
Nice.
You write a Java program, feed it a file, do regex for you.
Yeah.
Will you take points off if we write it in Latin? Would that even work?
I don't know. Let's find out.
I don't want to be
Yeah, I used to turn in like bogus assignments from non-existent students. I'm sure my teachers appreciated that. All right, other questions? So let's look at file I/O. So there's a file class, and one of the ways to construct this is with a path name. Okay, so it's just a string. We can put it in quotes, or we can read it from something, and it will try to open a file using that path name as the name of the file. So theoretically, this is very straightforward. So instead of constructing a new scanner on system.in, we'll construct a new file for data.txt, and we'll use that as the argument to scanner. Okay, because the scanner object understands constructors where you pass it a file as an argument. So this should open a file data.txt, and then when we read from that file, it should give us the tokens that it gets from that.
That file doesn't exist or create it, or just.
Oh, it's going to do even better stuff. But when we try to compile, okay, so as usual, we didn't tell it where file is, right? Good, so we have to import it.
So they're not like bundled together, they're just each have their own individual.
Some of them are bundled, some of them are different. When we get to Eclipse, you never have to worry about this. You just hit Alt-Enter, and it makes the import
Just
commands for you.
Java lang object and get literally everything.
Probably. I haven't tried that. So java.io.file.
I feel like that takes a little while.
You got 2 experiments to run. All right. So this will give us an error. And the error is unreported exception, file not found exception must be caught or declared to be thrown. And it's complaining about this scanner construction. Okay, so here's the problem. The file class, when we constructed with a path name, there's a possibility that that file does not exist, or we don't have access to it. And rather than just return a null or something like that, that constructor is going to do what's called throwing an exception. It's like a software version of an interrupt. It's going to say, hey, something went wrong, and your program's probably going to exit, all things being equal. So let's look at the constructor. And it tells us, oh, actually, it's just the null name. So it says it can throw this null pointer exception if the path name argument is null. And that can cause scanner to have some problems. So so we're going to work a lot with exceptions, okay? But here's the 6-minute version of exceptions. This statement down here can cause an exception. In Java, you can write code that says, if an exception happens, here's what I want you to do. And the general setup for this is what's called a try-catch block. So here's the idea. Here's a set of code that might fail. So we surround it with the keyword try and some brackets. And everything in here, we're warning the compiler, right? We know that this thing may fail. Okay, if it works normally, great, it gets down here, no problem. But if an error occurs in here, it hopes to find a catch block, and it'll execute this code in response to the exception. Okay, the catch block takes an argument. And the most general version of this argument is just exception, and we can just call it E, it doesn't matter. It's kind of like an argument list on a function, but it's not really a function. But you can think of it as if an exception occurs in here, it will kind of jump down to this chunk of code, right? It will set this argument E, in this case, to whatever the exception was, and then it'll execute this code. And then it continues beyond that closing bracket. If it goes through the whole try block and gets down here and there was no exception, then it skips over the catch block. Okay, hard to say, easy to see. So let's.
Does it skip the rest of the try? Or does it try to...
If it gets an exception, it leaves the try right there, it does the catch, and then it just moves on.
It's like a super cool if else.
Yeah, yeah. Okay, so we're going to put this in a try block. So we'll say something went wrong, and let's print out what the value of this argument E is. And then let's just return, because we don't want to try to read from the scanner if we got an error. All right, so here's our try block. If it succeeds, S should be set to that scanner object. If it fails, we should come down here in this exception block, this catch block. We'll print out a message, we'll print out the value of E, and we'll exit. So compiler is happy. We run Java main, and it tells us something went wrong, and then it shows us the value of E, which is this java.io file not found exception, data.txt, no such file or directory. But we could do whatever we want in that catch block, right? We could print our own message. We could go back and ask for a new file name. We could just abort silently. Doesn't matter. So let's make a data.txt. All right, there's our data.txt. Let's run main again. And this time it succeeds in opening the file, passes it to the scanner constructor, and then it runs our code, which prints out the tokens in that file. If we change the file to be unreadable and we run this, then we get a file not found exception, but it tells us permission denied. Okay, so that's, like I say, the 4-minute version of dealing with exceptions. There's a lot more we can say about this, and we'll go on to this later. But this doesn't, exception is a class, okay, and it's sort of the uber class of all exceptions, but there are other classes of particular types of exceptions, and we could say, if you get an IO file not found exception, then I want to do this. And we can have multiple catch blocks and say, if this exception occurs, do this code. If that exception occurs, do that code. And we can also create a finally block, which says when all of this is done, I still want you to do this chunk of code over here. So it's like a final catch-all. So we can put lots of stuff on here, but this is all we need to be able to work with things that potentially throw exceptions. And you don't need to do this in Eclipse because you can hit Alt-Enter and it will create the try-catch statements for you and put it around your code. It's crazy. Yeah?
Do you need to have a catch statement before you put finally, or can you just put finally?
I think you need a catch to be able to say try. I don't think you can just say try and finally.
Okay.
I'm not sure.
It's only gonna see the first like exception, right? It won't just like do multiple.
As soon as you get an exception, it'll go down to a catch block, right? And then if you want to do some more stuff from the try, you got to somehow get back up there. All right, cool. So I'll post a new ODP tomorrow morning, and we will talk more about something tomorrow. I'll post this code on the server also.